This is a video from section 7.3. The directions say to evaluate the integral. Let's take a look at number 9. Suppose we have the integral of x cubed times the square root of 16 plus x squared dx. And we're going to solve this integral by a method called trigonometric substitution. Now, what I want to do is I want to draw a right triangle. And so I'll draw that over here in blue, as you notice. And so here's a 90-degree angle right here. And we're going to call this angle theta. Okay? Now, before I start to label the triangle, I want to rewrite this integral as follows. So this is the integral of x cubed times the square root of x squared plus 4 squared dx. Now, let's take a look at this radical part. What does that tell me? The side opposite to angle theta in this triangle, we're going to call x. The side adjacent to angle theta is 4. And this is not a coincidence. By the Pythagorean theorem, the hypotenuse, notice, is the square root of x squared plus 4 squared. Okay. Now notice, if I take x over 4, opposite over adjacent, that's tangent theta. If I multiply both sides by 4, I get x equals 4 tangent theta. Dx is 4 secant squared theta d theta, right? Now, if I take the hypotenuse and divide it by the adjacent side, right, I get secant theta. That's what I have here. So in other words, I took the square root of x squared plus 4 squared, I divided it by 4, and I got secant theta. Multiply both sides by 4, and it says the square root of x squared plus 4 squared is 4 secant theta. Now let's come back to this. We have the integral of x cubed times the square root of x squared plus 4 squared dx. This is the integral of. Now remember, x is 4 tangent theta. So I'm going to take 4 tangent theta and I'm going to cube it. Now, the square root of x squared plus 4 squared is 4 secant theta. So I'm going to multiply by 4 secant theta, just like this. Let's go back. Dx is 4 secant squared theta d theta. Right here. Okay. So this is the integral of 4 cubed tangent cubed theta times 4 squared secant cubed theta d theta. Come over to here. So this is 4 to the 5th times the integral of secant cubed theta tangent cubed theta d theta. Right here. All right, now, this is what I'm going to do. Notice that the power of the secant is odd, and the power of the tangent is odd, right? So we have 2 odd powers right here. So I'm going to do this. I'm going to take 4 to the 5th, and I'm going to save a secant theta tangent theta. And then I'm going to multiply this by secant squared theta tangent squared theta d theta. We're almost done, right? Because, remember, 1 plus tangent squared theta is secant squared theta. So isn't tangent squared theta secant squared theta minus 1, right? And I just know that the derivative of secant theta is secant theta tangent theta, okay? And so I'm going to write 4 to the 5th times the integral of secant theta tangent theta, okay, times secant squared theta times secant squared theta minus 1 d theta. Now we're on the home stretch. Let u be secant theta. du is secant theta tangent theta d theta. And so this is 4 to the 5th times the integral of u squared times u squared minus 1 du. Okay? From here, distribute the u squared inside. So this is 4 to the 5th times the integral of, we get u to the 4th minus u squared du. So this is 4 to the 5th times 1/5 u to the 5th minus 1/3 u to the 3rd plus c. Okay, but what was u? U is secant theta. And even then, we're not done. So this is 4 to the 5th times 1/5 secant to the 5th theta minus 1/3 secant cubed theta plus c. Now, let's go back to the triangle. If we recall, we have a triangle here. Here's theta, here's x, here's 4. Here's the square root of x squared plus 16, okay, by the Pythagorean theorem. All right, now, so I'm going to get 4 to the 5th times 1/5 times. Now, don't forget, secant theta is the square root of x squared plus 16, okay, divided by 4. But I got to raise that to the 5th. Then I'm going to go minus 1/3 times square root of x squared plus 16 divided by 4 raised to the 3rd plus c. Now, I'm going to go a little bit further because I want to show you guys how we can simplify this. So this is 4 to the 5th times. Now, I'm going to go 1/5 times the square root of x squared plus 16 to the 5th divided by 4 to the 5th, right? And then I'm going to go minus 1/3 times x squared plus 16 to the 3rd divided by 4 to the 3rd plus c. But can't I distribute that 4 to the 5th inside? So when I distribute, I get 1/5 of the square root of x squared plus 16 to the 5th minus 1/3 times. Now remember, 4 to the 5th divided by 4 to the 3rd is 4 squared, right? So it's 1/3 of 16 times the square root of x squared plus 16 to the 3rd plus c. I hope that's okay. Remember, 4 to the 5th divided by 4 to the 3rd is 4 to the 2nd, right? Which is 16. That's where that number came in. And then just one last step here. So it's 1/5 of the square root of x squared plus 16 to the 5th minus 16/3 times the square root of x squared plus 16 to the 3rd plus c. And that's how we do problem number 9. And let's take a look at this one. We'll take a look at 13. Suppose I had the integral from 0 to a of 1 divided by x squared plus a squared raised to the 3/2 dx. And this is where a is positive. Okay, so let's draw a picture of a triangle here. Now notice how this is a definite integral. So we have limits of integration now. So I'm going to call this angle theta, okay? Now notice how we have a sum of squares. Now in this triangle, what that dictates to me is that the side opposite to angle theta is x. The side adjacent to angle theta is a. And then the hypotenuse is the square root of x squared plus a squared. Okay. Now, if I take x and divide it by a, so if I take the opposite side over the adjacent side, I get tangent theta. So multiplying both sides by a, that says x equals a tangent theta. Dx is a secant squared theta d theta. Right now, if I take the square root of x squared plus a squared and I divide it by a, I get secant theta. If I multiply both sides by a, I get the square root of x squared plus a squared is a secant theta. Now, we're almost ready to make our substitution, but not quite yet. Okay? What do we need to do? Couple things. I need to get an expression for x squared plus a squared to the 3/2. So, if you don't mind, can I say x squared plus a squared to the 1/2, right, equals a secant theta? Now, if I cube both sides, I get x squared plus a squared, and I'm going to raise that to the 3/2, and that's going to be a cubed secant cubed theta. So I just cube both sides. So that's for starters. Second piece. Now, remember, x equals a tangent theta. So let's double check that, right? That's from right here. Now, when x is a, notice that tangent theta equals 1. And so, therefore, theta is equal to pi over 4. When x is 0, tangent theta equals 0. So that says theta equals 0. Because why did I do that? Remember, these limits right here are in terms of x. And what we're trying to do is transform the entire integral to an integral in terms of theta. But that must include the limits also. Okay? Now, from here, we get the integral from 0 to a of 1 over x squared plus a squared to the 3 halves dx. This is the integral from 0 to pi over 4 of. Now, I'm going to get 1 over. Now, let's go back. X squared plus a squared to the 3 halves is a to the third secant cubed theta. So I'm going to put a to the third secant cubed theta. And then I'm going to multiply by. Now, let's go back. Dx. Dx is a secant squared theta d theta. So I'm going to put a secant squared theta d theta. Now, I'm going to pull the 1 over a squared out in front, and I'm going to integrate from 0 to pi over 4 of. Now, what it looks like is I get 1 over secant theta d theta. But what is 1 over secant theta? Cosine theta. So this is 1 over a squared times the integral from 0 to pi over 4 of cosine theta d theta. Now, because I transformed everything, and that includes limits in terms of theta, I don't have to put back the integral in terms of x. That's the advantage of trying to transform everything, okay? So we get 1 over a squared times sine of theta evaluated from 0 to pi over 4. So what's the answer? Remember, sine of 0 is 0, right? And then sine of pi over 4, right? Sine of pi over 4 is square root of 2 divided by 2. So we get 1 over a squared times square root of 2 divided by 2. That's my final answer for, this is number 13. Now, let's take a look at number 17. 17 is really interesting. So this is the integral from 0 to a half of x times the square root of 1 minus 4x squared dx. Now, this is an example of where we don't have to do a trigonometric substitution. Why do I say that? What's the derivative of x squared? The derivative of x squared is 2x. And so notice how we can make a substitution kind of like what we did in Calc 1. In other words, I'm going to let u equal 1 minus 4x squared. Du is negative 8x dx. And the reason why I'm going over a problem like 17 is because I always want you to look for the substitution first. If it's not there, then we do our, and what I mean by substitution, I mean the substitution that we did in the Calc 1 course, right? And if it's not there, we do the trigonometric substitution. So notice that x dx is negative 1/8 du, right? Now, when x is 0, right, what is u? So I'm going to replace x with 0 up here. And notice that u is 1, okay? If I replace x with 1/2, okay, so I'm going to put when, x is a half, u is 1 minus 4 times 1/2 raised to the second, and that's 0. So this is the integral from 1 to 0 of. Now, I'm going to pull the negative 1/8 out in front, and then I'm going to integrate square root of u du. But this is 1/8 the integral from 0 to 1 of square root of u du. So this is 1/8 times 2/3 u to the 3/2 evaluated from 0 to 1. The correct answer here should be 1/12. Because remember, 1 to the 3/2 is just 1. That's it. So that's how we do problem number 17. So we just needed a u substitution there. I want to talk about 21. If we have the integral from 0 to a, okay, and we get here x squared times the square root of a squared minus x squared dx. Now, let's draw a triangle. Okay? I'm going to label that angle theta. That's a right angle. Now, what this piece of the integral, or the integrand, tells me is that my hypotenuse is going to be a. The side opposite angle theta is x. And by the Pythagorean theorem, and again, it's not a coincidence, we're going to get the square root of a squared minus x squared. That's how we label our triangle. Now, notice, if I take the side opposite angle theta and divide by a, I get sine theta. The triangle dictates my substitution the whole time, okay? Multiply both sides by a, and we get x equals a sine theta. dx is a cosine theta d theta. Now, we still have to transform our limits in terms of theta, okay? And then I need to get an expression for the square root of a squared minus x squared, but we'll get that in a minute. Now, when x is 0, we have sine theta equals 0. And so that tells me theta equals 0. So notice I'm substituting right here. Or you can substitute up here too. Doesn't matter. When x is a, we have sine theta equals 1. And so theta equals pi over 2. So that's good. Now, one last thing. It turns out if I take the square root of a squared minus x squared and I divide it by a, I get cosine theta. And so the square root of a squared minus x squared is a cosine theta. Now, we're on the home stretch. So we're going to get the integral from 0 to pi over 2 of x is a sine theta. So x squared is a squared sine squared theta. So I get a squared sine squared theta times a cosine theta times a cosine theta d theta. So I'm going to pull the a to the fourth out in front. And I'm going to integrate from 0 to pi over 2 of sine squared theta times cosine squared theta d theta. So notice how the power of the sine and the cosine are even. So that's a little tricky. So we're going to integrate from 0 to pi over 2 of, and I'm going to drill you guys on the power reducing formula. So this is 1 minus cosine 2 theta divided by 2 times 1 plus cosine 2 theta divided by 2 d theta. And so this is a to the fourth over 4. And then I'm going to integrate from 0 to pi over 2. And then I'm going to get 1 minus cosine squared of 2 theta d theta. But isn't that sine squared of 2 theta? And so I'm going to integrate from 0 to pi over 2 of sine squared of 2 theta. Now, I'm almost done. So I get a to the fourth over 4 times the integral from 0 to pi over 2 of 1 minus cosine of 4 theta divided by 2 d theta. Now, I'm going to pull that 2 out, that 2 in the denominator out in front. And if you don't mind, I'm going to get a to the fourth over 8 times theta minus 1/4 sine of 4 theta evaluated from 0 up to pi over 2. Okay? Now, if I plug pi over 2 in for theta, I'm going to get 0 there. If I plug 0 in for theta, I'm going to get 0. Either which way. And so my final answer is going to be a to the fourth pi divided by 16. And that's going to conclude this video for section 7.3, and we did problems 9, 13, 17, 21, and I believe we stopped at 21. Okay. Thank you.